name is Carly McAvoy, and I'm your instructor for Math 98, and I'm going to do the video for homework 1B, talking about adding and subtracting negative and positive numbers. May have said this in the first video, but it's been a while since I've done that video, so I don't remember. If you have trouble with signed numbers and you're struggling in this first part of the course, probably means you should be taking the 94 course, where we spend more time and go over it in more detail. So keep that in mind. The first one here, as you can see on the screen, is -1 plus 17. The way I do these is to ask myself, what do I have more of? Do I have more negatives or do I have more positives? Let me make this a little bigger here, sorry. And obviously in this problem I have more positives. If you think about all these 17 positives being lined up and then just one negative, obviously there's going to be positives left over. That means that our final answer is going to be positive. I have one negative and 17 positives for a total of 16 positives. If I had the same problem, only I had 1 and -17, it's the same type of problem as in I have more negatives though here instead of positives, and so I've got a total of -16 because I had only one positive, but I had way more negatives in that case. If I have -1 and a -17, then I have all negatives. I have 17 negatives and I have another negative, so that makes that -18. And of course, if they're both positive, it would be +18. So you have to look at what do you have more of, negatives or positives. And if you have all positives or all negatives, then you don't have to ask yourself that question. You just add up all the negatives or add up all the positives. All right. So that one we said was 16. Remember, you have things over here that can help you with this work. Remember that this video over here is not my video. That's just a video for the book company puts out for that particular section. So we have 13/16 and -1/8. So I still am asking myself, do I have more negatives or do I have more positives? But I have to, first of all, before I can ask that question successfully, is make them have the same denominator. And the least common denominator for 16 and 8, LCD, is 16. So if I rewrite this problem, I wouldn't change the first one because it's already got 16ths. But for the second one, I need to multiply 8 times 2 to get 16. And I'd multiply -1 times 2 to get -2. And so what I would get over here is -2 16ths. That's just, I put parentheses around to separate these two signs, but all I did here was multiply the top and the bottom by 2 and gave myself an equivalent fraction that has the same denominator so that we can then compare those. So now your denominators are the same. You don't have to worry about the denominator. That denominator is going to stay the same as you finish that problem. What you're asking yourself instead is, what do I have on the top, more positives or more negatives? And you can look and see you've definitely got more positives. If you take 2 negatives, or take 2 away from 13, that's what you have left is 11. So that would be 11/16. Okay. The fraction thing is another issue people sometimes have, and if you're not good with fractions, if you email me, I will be happy to send you some links to some videos that I've done on how to work with fractions. Not negative and positive like we're doing, but just regular fractions, so you can kind of brush up on that. Here we have a difference, 7 minus 8. When you're looking at a difference of numbers, you can change it always into an addition problem. This is like saying you have $7 and somebody tries to take 8 away from you. If that happened, if you only had 7 and they took 8 away, you would be 1 in the hole. So it makes sense money-wise that we're going to have a -1. But what we can do here, especially if you're not very good at subtracting these numbers in your head, or you're new to it, then you would say this is minus becomes a plus, and 8 becomes a -8. And then you're going to add, just like we were doing before, 7 and -8 is -1, and that's what I would get for an answer. Let me grab my calculator. These problems you should be able to do in your head. You really should, because if you're spending time doing them on the calculator, you're going to waste a lot of your valuable time. But, you know, I don't want the fact that you can't do this math in your head to stop you from being successful in these classes. So I'm going to show you on the calculator something. Let's say I did this problem and I did 7, and I used this little sign down here, minus 8. It's going to say syntax error. This, by the way, is a TI-36X Pro, a very nice calculator for not a lot of money. This is the negative sign, and this is the subtraction sign. So if I clear that and I do 7, I do 7 minus 8, it's going to give me the -1. If I did 7 plus, that is this statement, 7 plus -8, then I would use the negative down here. That's the negative symbol, and this is the subtraction symbol. Then I hit enter, then I get -1 also. So either one of those gives me the same answer. Using your calculator or just using your brain, that's going to work out. Sorry to be turning that. Okay. So that's -1. You have to practice this stuff. If you're not good at it, how you get good is to practice, practice, practice. All right, -4 minus a -8. So it'd be great if in your head you thought of what that answer is before I say it and see if you get it right. Put it into your calculator if you want. We'll do that in a minute. If I want to rewrite this as an addition problem, I never change the first number. That's still going to be -4. The subtraction sign changes into an addition sign. And then the sign of the next one changes also, because -8 is +8. And that's that, you know, 2 negatives make a positive, like I don't got none, and you know, that's 2 negatives, so you do have some. Then it's the same thing with math. If you have 2 negatives in a row, 2 of these symbols in a row, they make a positive. And that's why we can make this change and have it be equal to the same. And now it's easy to see I've got more positives than negatives. So if these negatives canceled out as many positives as they could, we would still have 4 positives left over. So for an answer of +4. On the calculator, if I were to enter that, it would be -4. Because that's a negative sign, I would not be using the subtraction sign there. But then it is a subtraction, and then minus -8, and I get +4. You know, if you think you're not going to do any math in your life, but you don't really know. You have no idea what's going to come along, some opportunity where you have to be able to do payroll or something to get this promotion. And you know, you don't have to be able to do math in your head for that job or any other math job that you get, or job where there's a little bit of math involved, or maybe a lot if you're cutting down trees and you need to know how many board feet you're going to get out of a tree because you want to be able to charge the customer appropriately, or you know what the sawmill will only take certain size boards. I mean, there's a lot of times when math comes in that we don't think about it. You don't have to be able to do it in your head, but you have to be able to then be proficient with the calculator. So you should be practicing your calculator skills as well. You can do this problem a number of different ways. What I'm going to do is change everything into addition. This is not an addition sign in the front, that's a negative sign. I'm not changing that. That is the first term, I never change it. Here I have 2 negatives in a row, which makes that a plus. This one's already a plus, so I'm not going to change it. And over here, I'm going to say that this subtraction became a positive, and the 15 then becomes a negative. And now I can solve this problem. Maybe you'll see in the middle that you have a +9 and -9, and those two things are just going to go away, because if you have 9 positives and 9 negatives, they cancel each other out. If you saw that, then all you'd have left to do is say -15 here and -15 here. They're both negatives, they don't cancel each other out. I've got 15 negatives and 15 more negatives, so I have a total of 30 negatives. all negatives. When I said two negatives make a positive, that's if they're side by side like this, not if this is a negative over here and a negative over there. That's a different rule. This is basically suggesting multiplication. Okay, so negative 15 and negative 15 is negative 30. All right. Oh, we could do that on the calculator, but you should practice on the calculator for sure. I'm pretty good with the calculator, so I'm not really needing to practice this. But there are some of you that are really not that proficient with the calculator to the point that you just say, well, I'm not going to use them because they don't work for me or whatever. Then you need to get, because that's the thing I'm saying. You will maybe need to use a calculator on the job. You're never going to be asked to do math in your head on the job. So this is the more important skill, right? And by the way, you should probably get in the habit of actually putting in exactly the way it shows. We have negative 15 plus, or no, that wasn't how it was. It was negative 15 minus negative 9, but there's a parentheses, negative 9, plus, parentheses, negative 9, minus 15. And that's negative 30. So that's another way to check it. Okay, write an arithmetic expression for the given phrase and then simplify it. Oh, you guys can't see what I'm saying. I'll write it down here. No, you guys are looking at that, yeah. I'm going to write this down. The sum of 4 and negative 5. Okay. Let's take a look at what I wrote down. So I'm thinking I just did that calculator thing without you being able to see. Sorry about that. Anyway, this is what it looks like. Negative 15 minus negative 9 plus negative 9 minus 15 entered into the calculator correctly. The sum of 4 and negative 5, when we say sum, we're talking about an addition problem. If we say difference, we're talking about a subtraction problem. If we say product, we're talking about a multiplication problem, which we use a dot for multiplication or just parentheses for multiplication in algebra, and we don't use the X very often. And we use quotient to talk about division, and for division we usually use a fraction bar like 5 over 2 means 5 divided by 2. This means 5 times 2, right, when you put it in parentheses like that. So those are the symbols, but the important words for you to know. The sum of 4 and negative 5. The sum of means we're adding two things, and then we want to figure out, well, what are we adding? On the left, or the first one, we have 4, and the second one we have negative 5. So it looks like that. They may have not put the parentheses in because this program doesn't usually use the parentheses, but that's how I'm doing it. They did 4 plus negative 5. The sum of 4 and negative 5 is what? Well, we have 4 positives and 5 negatives, so hopefully you're starting to see that that would be a negative 1. If you don't see it yet, then use your calculator to get there. Subtract 8 from negative 3. What does that look like? Subtract 8 from something. So what has to go first? What has to go first is the negative 3. And you're going to subtract, so that's obviously a subtraction symbol, and we're going to subtract 8. So just because they say the word 8 first doesn't mean that 8 comes first. So we're subtracting 8 from negative 3. That's the way it's going to look. And then what do you get when you have negative 3 minus 8? Use your calculator to see. Or think of it this way. You have $3 in the hole, and then you owe another $8. How many dollars do you owe altogether? You didn't gain anything in this problem. You're losing, you're losing. So you actually are down $11. Right. All right, so the difference between 7 and 9, that's what we were trying to write here. And then we're going to simplify it after that. This is number 8. Write it down before you see me do it. That would be great. It says, doesn't say it says the difference between 7 and 9. Okay, and we're going to simplify it afterwards too. Alright, so we already know that the word difference means subtraction, so we're going to write a subtraction sign. When you see the word difference, whatever comes first has to go on the left, and whatever comes second has to go on the right. It's different up here because, or the one we just did a minute ago, because it said take 8 from 3 or whatever. This one says the difference, and when they say a difference, they state what comes first and they state what comes second. So that'd be 7 and 9. And actually, this is called the minuend, if you want to be technical about it. And this is the subtrahend. Some cool little vocabulary words that you probably don't remember from your grade school days. And so when I want to say the difference, I have to say the minuend first and the subtrahend second. Okay, so I'm going to change this into an addition problem, because subtraction makes that a plus. Because I changed this, I have to change the next one, so it becomes -9. That is equivalent statement. Think about it this way. You have $7 and somebody asks you for 9, you're $2 short, or $2 in the whole, -2. If you think of it this way, what do you have more of? Do you have more positives? Do you have more negatives? And the answer is you have more negatives by 2. So it's going to be -2. 7 minus 9 is -2. Right? I didn't read that correctly, or I didn't write it correctly. The question was actually the difference between -7 and 9. So it is a subtraction, so it's got to be the subtraction. And then whatever stated first has to be our minuend, which goes first, so that's -7, and our subtrahend is 9, that goes second, so that's it. But that changes the answer, because I thought it was +7 minus 9, which was -2, but it's not. It's -7 and -9. In this case, we don't have any positives. We're down 7, then we go down 9 more. So we're just going further and further into the hole. And so what would the answer be for this? Hopefully you said, we should check this part, where you said the answer is -16. Alright, select the answer that best completes the given statement. A negative number divided by a positive number is what kind of a number? This is something we really think you're coming into this class with the skills already intact. I'm going to write down the rules. These rules are for multiplying and dividing sign numbers. That means it could have a positive sign or a negative sign. These are the rules. If you have a an even number of negatives, you always get a positive answer. And if you have an odd number of negatives, you're always going to get a negative answer. And that's the rule. That's all there is to it. So if I have -3 times -4, that's 2 negatives. That's an even number, 2. So to have an even number of negatives, I'm going to get a positive 12. If I have -1 times -2 times negative 3. Notice I'm writing my multiplication with those parentheses. Then I have 1, 2, 3 negatives. 3 negatives, that's odd. So I'm going to get a negative answer. That's going to be negative 6. If I have negative 20 divided by negative 4, that's 2. That's going to give me a positive 5. If I have negative 15 divided by positive 3, I have 1 negative. 1's an odd number, so I get negative 5. So that's all you need to remember. Even number, negatives, positive, odd number, negative. Positive and negative. Sorry about my emails popping up here. A negative number divided by a positive number we just saw. That's 1 negative and 1 positive, so it would be a negative number. So multiply. I'm not going to write these down because you can do it on your calculator if you want, but 2 times 7 is 14. That's not the issue. I'm not concerned with that. If you need to do that on the calculator, that's fine. But what's the sign going to be? Well, we have 1 negative and 1 positive. 1 is a negative, is an odd number. If we have an odd number like that, then we get a negative answer. So it's going to be negative 14. Take a second for yourself to tell me. I'll tell you 8 times 4 is 32. What we're interested in is this positive 32 or is it negative 32? If you have an even number of negatives, those even numbers, those negative then cancel each other out and you get a positive answer, 32. What about this one? I don't know what 9 times 6 times 8 times 7 is, but I do know what the answer is going to be positive or negative wise because I've got 1, 2 negatives. That's an even number of negatives. So I know for sure that this is going to be a positive answer. Now, what do I don't know the rest of that. Let me write this down so I can do it on the calculator. I don't want you to spend all kinds of time multiplying something like that out. And no boss in the world is going to do that either. But that doesn't mean that you're going to take somebody else for math next quarter and they're going to say no calculators allowed on a test or whatever. That's everybody's philosophy. It's up to them. But for me, I just don't see the point in spending a lot of time doing those kind of calculations. Okay, at this level. I mean, when you're first starting off in math, it's good to learn how to do it. So let's see. I've got negative 9 times 6. Notice that we're using a dot for the times. Times parentheses negative 8 times 7. Now this is redundant. If I just put a parentheses in there, I don't think I need to put the multiplication symbol. But anyway, I hope you can see that. On one computer I'm seeing it, on the other screen I'm not. I really hope that you can see it a little bit. Try to bring the lights down in a way that would make sense. Anyway, I apologize if you can't see it. Anyway, and then hit enter. What we got was 3024. Obviously, positive answer. It's going to be positive because I only had 2 negatives. That's an even number. An even number always gives me a positive answer. 3024. Just be careful when you're entering that stuff in your calculator that you're doing it deliberately and slowly so that you don't misenter it. Alright, what about negative 8 to the second power? This is a good question. Well, we're going to look at this one in detail for a second. Some questions take a little longer than others. This problem actually says that we have this negative 8 is our base and 2 is our exponent. Okay, so this is our base and this is our exponent. And the exponent tells you how many times to repeat the base. So this problem says to do this. It says to do negative 8 times negative 8 twice. So we did it twice. That means that I have an even number of negatives, which is going to give me a positive 64 because 2 is an even number gives me a positive. But here's the problem. Sometimes you get this. Okay? Here, the base was the whole thing, parentheses -8. The base was repeated twice. Here, the base is just 8. That's different. Now I don't have parentheses around there, so this whole thing was in parentheses, so the whole thing was my base. Now what I actually have is I have this rogue negative out front, and then I have my base twice. That's what this problem says. No parentheses means that 8 is just the base. And so that's what gets repeated. And so I have one negative, and when that's an odd number, that gives me a negative answer, so that's going to be -64. If things are in parentheses, it's very nice. If I have -1 to the 4th power, I'm using 1 because 1 times 1 times 1 times 1 is still 1. It's easy to do. I know it's going to be 1, but is it negative or positive? Well, since I have an even number here, that means I'm going to repeat that an even number of times. And that gives me +1. But if I had -1, let's say, to the 65th power, which I'm not going to write out, I don't need to because I know that that means repeat -1, the entire thing, 65 times. That's an odd number. If it's an odd number, it's going to give me a negative answer, and I know that's going to be -1. If, on the other hand, I have -1 to the 4th power, what's the answer to that going to be? Well, what that looks like is 1, a negative out front, and then 1 times 1 times 1 times 1, or -1, because 1 is the base here. The 4 can only affect what it touches. If it touches the entire parentheses, then that's what it's touching. But here it's just touching the 1, so that's the only thing that's our base, and that's the only thing repeated. Alright, so that's one that comes up on tests, and people miss it over and over. And not just in 98, 94, 98, 99, it keeps happening. Alright, so 64. So you just want to practice, and if you don't remember, then put it into your calculator and do it. But when you put it into your calculator, put it in as it appears. Number 14 is -6 to the 2nd power. Would that be a positive or a negative answer? Ask yourself that while I... Whoops, that's not what I want to do. This is what I want to do. While I get over here to the screen, it looks like this jimmy jam right here, where I have a negative and then 6 times 6, and that's -36. Alright. Here's what I wanted to say earlier. Should have done maybe earlier. I'm really having trouble seeing that. Alright, that's kind of the best way. If I want to put in this problem, -8 to the 2nd power, look what happens if I just put in -8, and by the way, the squared button is right there. Just press that. In some calculators it's different. But anyway, if I want to do that and I just hit enter, that's going to give me -64 because what I just entered was this problem. My problem had parentheses around it. That makes it a different problem. So if I do parentheses, -8 in parentheses, and then square it, now I've got a different thing going on. I've got a +64. So you want to make sure when you're using your calculator that you don't just decide this symbol must not be important and leave it off. If it's in there, I would say put it in your calculator. 80% of the time it is important. Sometimes, like up here, the times and the parentheses kind of make that redundant. But you know, if you're newer to math, don't take the risk. Leave it on, because sometimes leaving that stuff on will definitely hurt you, but it never hurts to put it in. So there's your, how I would say. Just like, what about -1 to the 3rd power? Is the negative and the 1 repeating, or just the 1? You can look back at my previous example to see that would just be the 1 repeating. So I've got 1 negative out front and then 1s. So it's 1 negative, that's odd. It's going to be -1 overall. Remember, 1 to any power is still 1. Alright, I'm not going to spend a ton of time going over these because these are pretty easy. One thing, you can use your calculator, but two, you could probably just use your brain, because this fraction bar means a division problem. And when we're dividing, we go from top to bottom, so we're saying -21 divided by 7. Well, 21 divided by 7 is 3. So that part, hopefully those skills are in your head, and if they're not, those facts aren't in your head, then go use your calculator. But what about the sign here? I've got 1 negative and 1 positive, That's an odd number of negatives. When you have an odd number of negatives, you get a negative answer. So that's going to be negative 3. The number parts don't change. 21 divided by 7 is still going to be 3. That's a good part. What about when you divide by 0? Well, do this on your calculator. Anything. I don't even know what that top number was. Doesn't matter. I'm going to do 7 divided by 0. If you divide by 0 in your calculator and hit enter, it's going to say divide by 0 error, because the calculator can't do it. Your math instructor can't do it. You cannot do it. No one can do dividing by 0. Not possible. So let's say instead I do 0 divided by 7. That's 0. So you have to know the difference between dividing by 0 and dividing into 0. Dividing into 0 is 0. This says 7 goes into 0 0 times. That's quite clear. The other one says, how many times does nothing go into something? Well, if you don't have something, how do you decide that? So it's undefined when you divide by 0. And if you can't remember when it's which, then use your calculator. Any calculator in the world. This is another calculator that I have suggested in the past that people own, this little TI-30XS. No matter what calculator you do, if you take 7 and divide by 0, you're going to get an error message, right? Always, nobody can divide by 0, whatever calculator you're using. I wanted to show you this calculator for a second in case you have this one. It's also inexpensive. It's a little less expensive than the 36X Pro. The 36X Pro I really push because it's great for statistics. You can take it through 98, 99 statistics in one $20 purchase and you're done for calculators. This one is not as good for statistics. But anyway, if you're doing negative 8 to the second power, parentheses, negative 8 in parentheses, you can do the x squared, but let's say it was negative 8 to the fourth power or something. If you wanted to put a different power in there, you use this little caret button, takes you up, and then you can say like to the fourth power or something like that, and it'll do the fourth power for you. Fourth power, that's an even number, and no surprise then that we got a positive answer. All right, let's go back. Got off track a little bit. This one is undefined. We call it undefined because it's not possible to divide by 0. Okay, now we're going to do a kind of a creepy one. Well, I mean, it doesn't look very fun. To me, all these look fun. I see math and I see a puzzle to solve, and I like that. So I have a word problem and I first can't do it. I don't get like despondent. I get excited, like, oh cool, I got to figure this out, you know. So this negative 3, I'm going to write a 1 under it to make it into a improper fraction. So you're going to see that my problem looks like negative 5/11 and then the big fraction bar and then negative 3 over 1. So I've got the same problem written just slightly differently so that then I know this is a division symbol. This one means divide. Fraction bars mean divide. So I'm going to take negative 5/11 and I'm going to divide by negative 3 over 1. Remember what you do when you divide? You flip or find the reciprocal of the second term. You never flip the first term. First term always gets left alone. When you're adding and subtracting, same thing. It's always the second term that's happening too. My division becomes multiply. I flip the second one so I get negative 1/3. And then I multiply across. 2 negatives make a positive, and I get 5 over 33. 2 negatives, that's an even number. Even numbers always give me positive. Whether I'm doing fractions or decimals or whole numbers, those rules don't change. Okay, let's do this problem on the calculator on my TI-30X. I'll show you how great this is. This has a fraction button right here. So if I was going to do this problem, I would start by putting in my fraction button. And then I have a fraction on top, so I'm going to hit that again because I'm in the top blinking. So I hit that again, now I've got a fraction on the top. Now I'm going to enter negative 5, and I use my little arrow button here to go down over 11. And then I'm going to go down into the bottom and put, they had negative 3. Alright, so then I hit enter. And that gives me 5/33, which is what I got by doing it by hand. I like being able to do it by hand. I think everybody would like to do that, but I know some people don't. And so if you can't do it by hand, then do it on your calculator. But you have to be careful. When you enter your problem in a calculator, then stop and say, did I enter it correctly? So that's the thing. People say, well, people use calculators, and if they enter it wrong, the calculator gives them a wrong answer. They don't know the difference. Well, you probably didn't know the difference when you did it by hand and got it wrong either. So to me, that argument's a little lame. But it is true. You could be a little more careful about entering, and then you could get these answers right. All right. By the way, you can put a fraction in by clicking on this button up here. I just used the slash key on the keyboard and it turns it into a fraction, but if you didn't want to use that, you would click on this button and it would give you the fraction up there. Alright, use the commutative property to rewrite the following expression. In words, the commutative property, I'll write it down because if I say it, I'll say it too fast. Commutative property says, in words, changing the order doesn't change the answer. The answer, just one answer. So I can do A plus B and it equals B plus A, and those two things are still equal. It's true for multiplication as well. I can do A times B or B times A and I get the same answer. So that's what the commutative property says, is changing the order doesn't change the answer. When we're talking about the commutative property with addition, we just change the order of the things that are being added. Now, associative property, number 20, the associative property says changing the grouping doesn't change the answer. Remember this, you guys, as I'm writing this down. If you're just passively watching this video and not taking notes, you're not doing yourself any favors. And especially in the beginning, I know you're like, this stuff's so easy, I don't need to watch this video, you know, like whatever. Okay, you have to develop skills when it's easy so that when it gets harder, you've got some skills. And one of the skills is taking notes and then using your notes as you know, as a guiding principles as you go through and finish the homework. So my opinion, in order to be successful in math, you need to watch the video, make the notes, then go back and try the homework. And it may be in these first few sections or homework assignments, you don't need to use your notes because you do remember everything. But there's some stuff, and I bet that already a lot of you, commutative and associative property, did not spring to mind as rapidly as you might have hoped because we don't use it as often. So be doing your work in the correct way now. So when it gets harder, you've got a routine that's established and you'll be successful. You'll see as I do these videos, I mean, if you watch all the videos, I make mistakes all the time. I don't freak out about it. It's like, yeah, people make mistakes when they do math. People make mistakes when we speak. We stumble over a word or say the same wrong word. We chuckle about it. We move on. It doesn't mean you shut down and go, well, can't do math. I made that mistake. Now I'm done. I mean, come on. We all make mistakes. Get over it and move on. Okay, so changing the grouping doesn't change the answers. If I have something like this, and I regroup it, what we mean by grouping is that these are grouping symbols, the parentheses. Y plus Z are grouped together, but I can then group it differently and put Y plus X together. Notice I didn't change the order, X, Y, Z, X, Y, Z. If I change the order, that would be the commutative property. If I just change the grouping symbols, pick them up and move them, that's associative property. It can be done with multiplication as well. I could have A and then B and C in parentheses. I could just move those parentheses and put the A and B and leave the C outside. That's all the same thing. So I can change the grouping and it doesn't change the answer. Okay, so up here, what I have is, I'm going to move the group, I'm going to put these things in order. Notice that I have P plus 16 plus Q. I'm not changing that order. That has to stay the same for the associative. But over here where P is in parentheses, I'm going to leave it out. And I'm going to put the parentheses around the 16 and the Q. 16 was with P, now 16 is with Q. Alright, the distributive property is a way to get rid of parentheses. So we multiply to get rid of the parentheses using the distributive property. This problem I'll write down negative 4a minus n. Hopefully you've seen the distributive, well, you have to have seen the distributive property before. You may not remember it, but sometimes having seen it makes it a little easier to digest it. And the distributive property, I don't really have a great way to say it, but how I'm going to say it is this. We multiply, we don't spell multiply wrong, we multiply to get rid of parentheses. I didn't get rid of the parentheses up here, I moved them, right? So over down here I want to get rid of them, and I'm going to show you an easier example before we do that one. Let's say I have A and then times B plus C. I would say to get rid of these I'm going to multiply. A times B is AB, this is a plus, and then A times C is AC. There I got rid of the parentheses, I multiplied those out to get rid of them, and that worked out nicely. Let's say I had negative A times B plus C. Negative A times B is negative AB, and negative A times C is negative AC. How do I know it's negative? Because I got one negative times a positive. That makes a negative. One negative times a positive makes a negative. And so I have that now becomes minus minus because multiplying negative A times positive C made it negative overall. This is the thing about having a calculator that you do things on. When you get into these where you're multiplying by letters, the calculator isn't going to be very helpful. So you want to be able to do this without a calculator. So we're going to take negative 4 times A. I've got one negative and one positive. That's a negative 4A. And I've got negative 4 times negative M. Negative times a negative is a positive 4M. Because I have negative 4 and negative M. And in detail what that looks like, if you want to see, I'm doing negative 4 times A plus negative 4 times negative M. I'm always putting a plus in between those two things because they're two separate things. So that gave me one negative, one positive is negative. Two negatives here made that positive overall. Okay, so this is the final answer, negative 4A plus 4M. And while we're at it, I'm going to show you this. If I have, let's say, 7 minus M minus 5, if you look at that problem, the number outside the parentheses that you're distributing is not 7. That has nothing to do with that. This is a little negative 1, even though we don't see it. It's negative 1 times M. It's negative 1 times negative 5. And then we could finish that problem out. But the point is, the number out front has to be exactly beside no symbol inside there. There's no addition or subtraction. If it's just beside there, that means multiply and get rid of the parentheses. But if there's some other symbol there, that means that number doesn't have anything to do with that. And so you wouldn't multiply by it. That's just a really common mistake I just wanted to point out. So we said this was negative 4A plus 4M. State the property or properties that the equation illustrates. Well, we started off parentheses and we ended up without parentheses. So which one was that? The commutative property says we can change the order. The associative property says we can change the grouping. And these are just for addition, for multiplication, whatever. But distributive property is the only one that allows us to get rid of parentheses. And notice 6 times 5 is 30. and 6 times D is 6D. Now this property is different because we're not changing the order. We didn't get rid of parentheses. We didn't change the grouping, so we haven't used any of the ones that we know so far. Instead, it says that T plus 0 equals T. So when I have a problem, I have a number, and I add something to it and it doesn't change it, then we would say that it kept its own identity, right? So that's the identity property. Adding or multiplying by a number doesn't change the initial value. We have initial value of T, we add to it, but we still have T. That means we use the identity property. What number would I multiply to make that happen? In other words, I start with T, I multiply by something, but I still have T. That would be 1, right? So maybe you said that. That's the identity for multiplication is 1. The identity for addition is 0. That's nice for me to cover up what you're trying to copy. Okay. Always pause or slow down the video if I'm going too fast. So this is the identity property. It kept its own identity even though we added something to it. And well, we know for sure it's not the distributive property because we didn't even start off with any parentheses to get rid of. The commutative property says change the order. This isn't changing the order, this is just different. The associative property says changing the grouping. We didn't have any grouping. Kind of by default, it's got to be multiplicative inverse. But let's talk about what the inverse properties say. This is number 24. This is a long assignment, but it doesn't take that long if you know what you're doing. If you don't know what you're doing, you spend more time. That's how life is, right? It's not fair. Some people are going to spend more time. Some people are going to spend less time. This one says 1 over SF times SF equals 1. And also think of it this way, you know, when you get to the top of a mountain, you got a great view. Maybe you went straight up, maybe you had to go around and around a bunch of switchbacks because you couldn't handle the steepness, okay? You still get to the top, you still get the view, don't worry about it, just get there, right? Don't quit because you have to work a little harder than somebody else. The additive inverse, that's not what this is obviously multiplication. The additive inverse says that if you add opposites, you get what? 0. The additive inverse just says adding opposites gives you 0. The multiplicative, I love that word, I don't know why. Multiplicative inverse says that if you multiply something by its reciprocal, you get 1. Obviously, right? If you take 3 and multiply by 1/3, you get 1. So the multiplicative inverse says that if you multiply something by its reciprocal, then you get 1. And the additive inverse says if you add opposites, you get 0. So they're two different ideas, but they both have, you know, they're both called inverse properties. So this is obviously a multiplicative inverse. Here's the S of F, and if you flip that upside down, its reciprocal is 1 over S of F, and those two things equals 1, because the S of F's will cancel on top and bottom and leaving just 1 behind in the wake. So that's a multiplicative inverse. Here's the thing that kind of, well, there's many different things that peeve me off about students, but hopefully there's a lot more that make me really excited, and I love teaching math. But I don't like when people say, well, I can do the math, I just don't know any of those properties and stuff like that. You know, if you're doing math, properties are part of it. It's a vocabulary like any language. You have to learn the language to be proficient at it. So don't just blow those off as like not mathy enough for your, you know, attention, because it's all important. All right, select the best answer that completes the given statement. When variables and numbers are multiplied, they are called, well, I'm going to choose factors here. I've not done this problem for a while, but factors are parts of a multiplication problem, right? So when you multiply something, they're called factors because we're multiplying those. So when they are added and subtracted, they are called terms. We have separate terms. Terms are separated by addition and subtraction. So let me write down so you can see what we're talking about here. I think this was number 25. If I have 3x plus 7y, 3x as a whole is a term, and 7y as a whole is another term. So we would say we have two terms in that problem. But if I just look at 3x, that means 3 times x, and that means that 3 is a factor and x is a factor because they're both part of that multiplication problem. So if you're just multiplying them, they're factors. If it's part of a bigger problem, then they're terms. But these parts of the factors have terms. The x is the variable because it can change from problem to problem. And the 3 is the, anybody remember what that's called? Coefficient. The coefficient is the number that multiplies the variable. So they're both factors, but they have their special terms, the coefficient and the variable. In this term, 7 is the coefficient and y is the variable. These two things are not like terms. Like terms mean they have the same variable. And since they have different variables, we can't add those together. So I'm going to write that down now because it's bound to come up. And I'm here. Like terms have the same variable to the same power. You can only add and subtract like terms. Okay, so I can't do anything with this. This is like apples and oranges, right? Everybody always says that in, explaining things. This is two different things. I can't put them together. But if I have 3x and then add 4x, now all of a sudden I have like terms. They have the same variable, they're to the same power. Now I can say I have 3 of those and I have 4 more of those. I have a total of 7 of those things. I don't have 7 y's or 7x squared or 7 z's. I have 7 x's. I had 3, got 4 more. I have a total of 7 x's. All right, we'll come back to that. Select the answer that best completes the given statement. We can add or subtract only like terms. I just said that. I'm psychic. That was coming. Knew it was coming. Okay. Give the numerical coefficient of the term. The coefficient, this is one single term, but these are both factors. The coefficient is the number that multiplies the variable. It's not the exponent, that's the degree. That's called the degree of the term. This is a second degree term because it's to the second power. But the numerical coefficient is just that number in the front, which is just 3. If that was negative 3m squared, the coefficient would be negative 3. It has negatives. The coefficient could be negative or positive. Could be a fraction or a decimal too. Now it's saying combine the terms if possible. Is it possible to combine 6x and 10x? Are they like terms? That's what we're asking first. Are these like terms? Because if they're not like terms, we can't put them together. But it turns out they both have the same variable x and they're both to the same power. So yes, I can combine these. I have 10 of these things and I take 6 away. It doesn't matter. If I had 10 houses and I sold 6 of them, how many houses do I have left? I have 4 houses. I don't just have 4. I have 4 of those things. So it's 4x. I have 10x. I take 6 of them away and I've got 4 x's left. What about this one? Can I combine these 7x plus 2y? Well, they're not like terms. One has an x and one has a y. So in the example I showed you in the paper a minute ago, we can't do anything with that because they don't have the same variable. They're not like terms. They can't be simplified. All right, now we're getting into something a little more interesting here. Well, all of it's interesting, but I mean a little more tricky, I guess I should say. We have negative 6 plus 9z plus 3 minus 2z. Okay, so I have some like terms in here, and I have some terms that are not like terms, but what are the like terms? I have a 9z and a negative 2z. Those are my like terms. And then I have 6 and negative 3, negative 6 and positive 3. I know I can combine those. I've been doing that my whole life, right? Or since we started doing negative numbers, it's been like, what, 20 minutes? Anyway, we have 9z minus 2z, okay? And then over here, you've got negative 6 plus 3. I just changed the order of that problem. Whoa, what property did I use? Changing the order doesn't change the answer, and that's the commutative property. The commutative property says you can change the order. And so now you know, like, well, why would I want to change the order? This is why. We can put our like terms together, and then we can simplify. If I have 9 z's and I take 2 z's away, how many z's do I have left? You have 7z. Think about if I have 7 pencils and I add 3 pencils, I have 10 pencils. That unit at the end doesn't change. I don't have 10 whiteboard markers all of a sudden. I've got the same thing that I started off with, just more of them or less of them. So that's why the z is still just z. Here I have negative 6 and positive 3. You can put it on your calculator, or you can ask yourself, what do you have more of? Do you have more negatives? This is like a negative 6, or do you have more positives? And the answer is you have more negatives by 3, so it's a negative 3. Feel free to put that into your calculator to check it, this part right here. But I can see that that's going to be the case. Some people say, well, how do you know if it's a negative or when it's a negative, when it's a subtraction? It's the same thing, because we can always rewrite our subtraction to look like this. I can always change the subtraction into a plus and negative. So since I can make that change, I can think of it as a negative 6 right here, kind of doing that in my head, saying, well, that's actually like a negative 6 and a positive 3. That's going to save you time. Work on it. You want to get to that. But if you want to carry the calculator around and try to do everything in your calculator, that's your choice too. Okay, we're going to simplify this expression. This is not easy. This is getting tricky, and you know, part of it is because of the signs, and you can't do all this on your calculator because you got variables in there, but you can do parts of it on your calculator. If you know that you're going to have a z coming along, you could do on your calculator the negative 3 times 3 part and then just bring the z along. What happens though is people forget to do that, so you want to be careful. If you're not putting everything into your calculator, you got to remember that it's there when you write your answer down. Most everything in these kind of problems can be solved by being careful and meticulous. Some people are not careful, meticulous people. And I've kind of come to find that people that are good at math are a little more attention to detail and all that because they see those things. So if you weren't good in math before, maybe you'll become good in math now. And one of the things you want to work on is making sure that you're being meticulous, that you're writing the problem down correctly, that you're putting into your calculator correctly, that you're not leaving things off. That's going to help you a ton. And if it doesn't come naturally to you, that's something you really want to work on. To me, it comes naturally. I'm very nitpicky by nature, so maybe that's why I teach math. Okay, so we're going to do this. Negative 3 times 3z. Well, the z comes along for the ride. But I have to figure out what's negative 3 times positive 3. I have one negative and one positive. That's more negative. That's one negative. Sorry, not more. That's one negative. Multiplication and division rules. If you have an odd number of negatives, you get a negative answer. So that's going to be negative 9z. All right. Now I'm doing the second part, which is negative 3 times negative 6y. If I write this up to the side here, negative 3 times negative 6y, you can see that I can change that using the associative property. Whoops. Yeah. Put the negative 3 and the negative 6 together and boot the y out. The y is not gone, but it's just not what we're working with right now. I have negative and a negative, which is a positive. Positive 18y. And then I have this straggler down here that has nothing to do with my parentheses. What property did I just use to get rid of those parentheses? That was the distributive property. Good. So I just used that, but now I'm not done because I have like terms again. So I'm going to use that commutative property and change the order of my problem. I'm going to change that negative z, I'm going to bring that over here. If you move things around, it has to keep the symbol that was in front of it. So The 18y had a plus, so that's going to bring along that. This is a little confusing. If you just have z, or negative z, that's like negative 1z, right? We don't say negative 1z. We don't say 1z. We wouldn't do that in life. If you said, oh, how old's your boyfriend? You don't say, oh, he's 1 times 24. I mean, why would you do it? You don't need to. It's still true. But nobody says the 1 because it's understood there's one of those things. If we didn't have one of them, we wouldn't have it there, right? So we understand that there's a 1 there. So this is like a negative 1. You can write it in if that makes it helpful to you. So what I have is 9 negatives and another negative. I'm dealing with z's, so I know I'm going to have a z in my answer. But what I'm interested in is what am I going to get when I take negative 9 and negative 1 and combine them. I'm 9 down, I go 1 more down. I don't have opposites here, I have the same symbol, so that's going to give me a total of negative 10. And this is my final answer because the y and z, not like terms, can't put those together. That's as far as I can get. So what do we have? Negative 10z plus 18y. Alright, we're almost done. Stick with me here. We're going to do this. When I talked about this a little earlier, what happens when you see a negative sign in front of a parentheses and nothing else? This is 32. This is negative 3y minus 7 plus 11. Okay, so we're going to do, oh, I guess you want to see what I'm working on over here. We're going to get rid of these parentheses by using the distributive property. This negative out front, even though we don't see it, it's like having a negative 1 there. So I'm actually going to take negative 1 times 3y. That's 1 negative and 1 positive, which gives me a negative overall. So that gives me negative 3y. And then I'm going to take negative 1 times negative 7. That's a negative times a negative. Or 2 negatives, that's an even number. That gives me a positive 7. Understand that when I'm making these symbols, I'm talking about multiplying those two things. So this is like a little multiply and multiply, and multiplying these two and multiplying those two. That gets rid of the parentheses using the distributive property. Now there's a 1y term in there that nothing else, so that's not going to change. But I can combine these together. So remember, they're all positives. There's no negatives. You're just adding those together, just like you would with all negatives. So I've got a total of 18 positives. Don't forget your basic math skills when you get into this, because sometimes people will be like, negative 4 or something. All positives, you've been doing that for a long time. Okay, negative 3y plus 18. You know, you're not sitting here taking this class if you're a dummy. You're a smart person. So, start thinking that way about math. Not just about, well, I'm good at English, but I'm not so good at math, or I'm good at history, or I'm good at, you know, fixing cars, but I can't do math. You can, you will. If you stick with it, you'll get it. You just have to have the right attitude attached to it. So please try not to be wallowing in your negativity. It will definitely hinder your ability to learn. Okay. There's a negative 1 in front of that. That negative 3x in the front has nothing to do with this thing over here. This is just a term floating around in its own little world. So that's going to come straight down unchanged. Now I'm going to take negative 1 times 5x. Remember, every time you see a negative in front of parentheses, there's an imaginary 1 there. And so negative 1 times 5x, negative times a positive makes that negative 5x. And then I have, means multiply when I'm writing that. Now I'm going to do this one, negative 1 times positive 1. I've got 1 negative and 1 positive. Odd number of negatives gives you a negative every time. So that's a nice thing about math. You know, it's not like, well, whatever it is, I before E, except after C, except as in A, as in neighbor and way, or whatever. These exceptions they throw at you in English, we don't do that in math. It's way more pure. We just do this, this thing as it is. Negative 3x, negative 5x, total of x's. But I have 3 negatives and 5 more negatives. Just like up here, if I have all positives, I get a positive. If I have all negatives, I get a negative. So I have negative 3 and negative 5 totaling up to negative 8. That part you could put in your calculator as long as you don't forget to bring the x along. And then minus 1. Negative 5x minus 1. There's no rule that says you can't watch the videos multiple times. Whoops. Oh. How did I get negative 3 and negative 5 was negative 5? Okay, so that's a mistake I just made. Go back. Hopefully you guys everybody was like snickering at me. 3 negatives and 5 negatives is a total of 8 negatives. I should have put that on my calculator. But you know what? Sometimes you just make a mistake that you know the answer to, and those little mistakes are the ones that people like, oh, I'm so frustrated with the little mistakes. I make little mistakes. If every time I make a key for a test, I usually have 2 or 3 that I get wrong because of a little mistake. I don't think, question, do I really know this math? No, it's the big mistakes you worry about. The little ones are like annoying, but when you have a major concept, that's the ones that are concerning. Everybody makes the little stuff. If you make so many little mistakes that it's costing you the game, then you want to think about that. Okay. This is a division problem. When you divide, you use the rules that we talked about for multiplying and dividing. When you have this is called a binomial because it's 2 terms on the top. This is a monomial because it's 1 term. You just rewrite both of these so that each of these has its own chance to be divided by that 3. That's really what's happening. So you can do it in your head, but I just rewrite it into 2 parts always. And then I'm just simplifying. This is a division. 15 divided by 3. It's all positive, so it's going to be a positive 5x. And then over here I've got a minus, and 6 divided by 3 is 2. This minus sign just came straight down. It didn't affect what I was doing there. Okay. But if I had this, negative 6 divided by negative 3, then it's different. Because now I have 2 negative signs. And when I have 2 negative signs in a row like that, that makes that a positive. That'd be a positive 2. So just be careful with that. 5x minus 2. Really is 5x this time. I got a little gun shy with the 5x answer. Okay. Now we're going to simplify using order of operations. This is number 35. Negative 6 to the 2nd power minus 7. Without looking back in your notes, can you tell me whether negative 6 squared is going to be positive or negative? Well, the thing about that is, the base is 6 here, so it actually looks like negative 6 times 6. It does not look like negative 6 times negative 6, so it's a negative answer because we only have 1 negative. Negative 36 minus 7. Well, in this case, I have all negatives. There's no positives, so I've got negatives. I'm getting more negatives. I'm going to have just a bigger negative number. How many negatives do I have altogether? Well, 36 and 7 is going to be 42, so I've got negative 42 altogether. And if you don't know that, put it into your calculator. I haven't used a calculator for a little while here, so I'll do it. Negative 36 minus 7 is negative 43. So did I do that on purpose or not? Well, the thing is, sometimes you think you know an answer, and so you just write it down and move on. You've got this calculator that you could use to check things. Check it. It doesn't hurt anything to check once in a while, and then you avoid making mistakes, especially on a test. So those are the little mistakes that I'm like, you had a calculator right there, why didn't you check it? And everyone's like, well, I thought I knew it. Sometimes you think you know it, but you've got a little mistake going on, and so you really want to take the time to use your calculator. But if you're just putting this straight into your calculator, you are losing beneficial practice of this, because there are going to be times when there's variables involved and you need to have some practice doing this. So my strong suggestion, which people will probably ignore, is to try the problem on paper, then put it into your calculator to check. And in math, online, I don't get to see your work. If it was a classroom setting, I would look for show me your work. It's one of the benefits of online is I can't see your work, but the bad thing about that is sometimes you get a false sense of security because you're working at home and nobody's really checking into it. And especially if you have a tutor sitting next to you, you think, your tutor's just helping you, but they're stopping you every time you get ready to do something wrong, or they're getting you back on track as soon as you, or giving you a hint. And so it's really different taking a test by yourself. This is the acronym for the order of operations: parentheses, exponents, multiply and divide, add and subtract. Some people call it PEMDAS. Some people say, please excuse my dear Aunt Sally. The reason I don't like either of these is because it looks like multiply always comes before divide, and it doesn't. It's whichever comes first from left to right. But we don't have any parentheses in here. We do have exponents. I'm going to do that. 4 to the second power is 16. I could check that on the calculator, but I'm feeling really confident. 3 to the second is 9. Everything else, notice I wrote it down. Oh, you're not noticing because I didn't switch it over to the camera. Sorry. The please excuse my dear Aunt Sally was what I was saying. And that's parentheses, exponents, multiply and divide, whichever comes first left to right, add and subtract, whichever comes first left to right. We don't have any parentheses, so I did the exponents. 4 squared is 16, 3 squared is 9. Okay, so then I'm going to go back and do multiply and divide. But I'm not going to jump over here and do this, because multiply and divide is whichever comes first from left to right. So the 16 and the minus, no business of mine yet. But here, 36 divided by 9, that's the next thing that comes from left to right. So that's going to be 4. And now I'm going to go back and do that multiplication. And that's 4 times 3 is 12. And then 16 minus 12 is 4. And 4 minus 7, now you're faced with a sign problem. Is it going to be negative or positive? It's going to be negative, because you've got 4 positives and 7 negatives. If you want to rewrite it, that minus becomes a plus, 7 becomes a negative 7, and then you say, okay, I've got more negatives by 3. You can also think of it as you have $4 in your wallet, something costs $7, you are $3 short, or $3 in the hole. Alright, so those, I think if you think about it as money, it's sometimes very helpful. Okay, so that's what I thought was negative 3. 7, I have 5 times 7 minus 9 to the third power, minus 7, 1 minus 3 to the third power. So on this problem, I copied it down incorrectly, very carelessly, as I was just suggesting, and I got it wrong because I wrote down a second power here instead of a third power. So I'm doing it over. I'm not going to show you the first work. I mean, you can see the work up there for the first one that I did. But the problem with that is it's confusing to follow that and then find out we're wrong. So I'm just going to go back and redo it. Inside the parentheses first, I have 7 minus 9. I have more negatives, or I want to think of it this way. I have 7. I'm taking 9 away. That leaves me in the hole. Notice that the 5 out front doesn't change. I haven't done anything with the power yet, because the rule is parentheses and then exponents. So I don't just jump in and start with the exponents. Then I'm going to do what's inside the second set of parentheses. I have 1. I take 3 away. That also leaves me 2 in the hole. Excuse me. And then I'm going to do the powers. Negative 2 to the third power. That's 3 negatives, or negative 8. And this is 3 negatives, or negative 8 again. You can do that on your calculator. Negative 2 times negative 2. This is what it looks like. Negative 2 times negative 2 times negative 2. There's 3 negatives, which makes it negative, and 2 times 2 times 2 is what makes it 8. 5 times negative 8 is negative 40. Negative 7 times negative 8 is positive 56. Now I have some negatives and I have some positives. What do I have more of? I actually have more positives. So I'm actually going to subtract the 2. Like these 40 negatives come over and subtract 40 of my positives, and then I see what's left. If I take 40 away from 56, I'm left with 16. It's positive because there were more positives than negatives to start with. So let's put in my new answer, having written the problem correctly. That's my just bragging about how I'm good at details, and then I missed it. Well, nobody's perfect. That's the thing. I'm not thinking that I'm bad at math. I just think I made that one mistake. Alright, 6 minus 3. So I have parentheses, and people say, oh, it throws me off when I have those other kind of parentheses, in other words, the brackets that are in there. So let me just say something about that. These are grouping symbols. They could be parentheses, they could be brackets, they could be braces. They all have the same meaning. We use the parentheses more because they're easier, quicker to write. But it's hard, it gets confusing if you put parentheses next to parentheses. So this same problem, if you did this, it's just harder to look at because they got all these parentheses in there. So we alternate just to make it easier to read, that's all. But they have the same rules, and they're considered parentheses. We do what's inside there first. But we go to the innermost parentheses and do 6 minus 3, which hopefully no challenge for anybody to say that that's 3. And then inside the brackets, we're going to multiply 2 times 3, which is 6. And then 6 to the second power is 36. All right, so 36 for that one. These order of operation problems, people are not good at them in 99, wherever I've ever taught math, they're not good at them. So it's something that you want to spend a little time practicing. Some of the common mistakes people do is to jump over multiplication, do division first, or to take the exponent, distribute it through the parentheses when you should be just working inside the parentheses first, and so forth. So just give yourself a chance to do several of these and kind of practice it and see how you're doing. Let me see if I wrote this down correctly. 3 to the third minus 4. Okay, got it. All right, so now we have 2 to the, I'm going to do innermost parentheses first. I've got outer parentheses, inner parentheses, but innermost here, I've got a subtraction and an exponent, so I'm going to do the exponent first. 2 to the third power is 8. Then inside this parentheses, 8 minus 4 is 4. You might be asking, why didn't you distribute right there? The distributive property is for when you can't follow the order of operations. You have to get rid of the parentheses because you, for some reason, can't follow the order of operations. That's when I would use it. If I use it here, it wouldn't make it wrong. I could still get the right answer, but there's more chance for mistakes. So I'm going to follow the order of operations. Simplify inside there as much as I can. Now inside these parentheses, I have addition and multiplication. I'm going to always do multiplication before addition unless there's parentheses to tell me differently. So that's 12, and then 3 plus 12 is 15. Now I don't need the brackets anymore because there's nothing left to do in there. And then I have 15 divided by 9, and that looks like 15 over 9. And if I divide both of those by 3 to reduce, I get 5/3. People do not like fractional answers. They really like decimals, but you know what? The rest of the math world, we like fractions, so get used to that. Simplify that, and that becomes, I'm going to say 5 over 3, and get it right. Last one. You guys slogged through with me. Nice job. Let's do this one and be done for a little while. 6 times negative 6 minus 5 times negative 6 all over 2 minus 7. When you do this problem, you do the top independently of the denominator until you get to the last step, and then you combine them into a fraction. So we have 6 and negative 6 multiplying, so that's going to be negative 36. Negative 5 and negative 6. Remember, when you see a subtraction in front of that, that can be a plus a negative, so it might as well think of it as a negative 5. Negative 5 and negative 6 is positive 30. And down below, I have 2. I take 7 away. I'm going to be 5 in the whole. And then what do I have more of on the top? I have more negatives than positives. I have more negatives by 6. So I have negative 6 and negative 5. And the 2 negatives cancel each other out because 2 negatives make a positive when you're multiplying or dividing. And so I just get 6/5. Again, got a fractional answer. Totally fine with that. Love the fractions. Alright, so 6. Alright, you got through homework 1B. I hope you have a fantastic day. I'll see you here next time.